All right, hey folks, Mark Locklear here with a screencast on Chapter 2, how to write your first programs. So this is really a good chapter. I think it's well done. I want to encourage you to read it, digest all of it, and certainly let me know if you have questions, because really everything else we do in this class is going to be based off everything they're covering in Chapter 2 here. So I'm going to hit a couple of high points as far as chapter content goes, say a few words about those, and then I think what I'll do is I'm asking you to complete Project 2.2 in the project workbook or project PDF. I think I'll code a little bit of that just to get you started, and we'll work through that. So, and I'm looking off to the side here. I apologize, but I'm just looking at the chapter and the topics. The first part, basic coding skills, how to code comments, and then the main function. Comments are simply code or text inside a program that's not processed by the compiler, and from a functional standpoint has really no purpose whatsoever, other than basically it serves as documentation. Okay, so for instance, I'm asking you to put your name, the class, and the date at the top in the comment section of each of the applications that you're submitting for homework. So when you run the program, that has no effect on the program at all. You could put gibberish in there. It's not processed by the compiler, and it's generally just there for, and again, just what it says, they're comments. You generally put them at the top. You may have some licensing information at the top, maybe the name of the person that wrote the code. And then generally you'll see comments throughout programs lots of times documenting functionality or whatever else the programmer might want to communicate, either to themselves when they come back and maybe look at the code down the road, or to other people who may be looking at their code. So that's that section. They mentioned the main function too. So basically everything you'll be doing here is inside that main function. The main function is the entry point for the program when it's compiled and ran. That's where everything starts. Now you may have associated files, classes, modules, other things outside that main function. They're going to be called there, but that's always the entry point for the program and where it runs. The next section is on input and output. So this is hugely important. We'll talk about CIN and COUT, but basically that's a way to output text on the screen. So all of our applications are going to be console based. There's no GUI. So if you're used to working obviously in Windows and Mac, you've got a nice what's called a GUI interface, GUI, which is graphical user interface. Prior to the mid 90s or so, and I'm old enough to remember those times, everyone worked on consoles. You just had a text screen. In fact, there were even web browsers. The first web browser I ever interacted with was called Lynx, and it was a text-based web browser, if you can imagine that. So feel free to Google it and see what it looks like, but everything was text-based. So that's the way we'll be working here. Our focus is more on the functions, data structures, handling data, getting input and output. So that's why we're doing everything inside the console. And when we talk about C++, you don't generally think of GUI programs when you think of those. And that's not to say that C is not used on the back end of some GUI applications, but generally C and C++ is concerned with what we call sort of back-end server operations, the manipulation of data, calculations, those kinds of things. And then that data may be handed off to some other application that sort of has a GUI interface or a web interface with it, but everything we'll be doing is in the console. So when we code up, when we do our little coding exercise here in a second, I'll say a few more words about those things. The standard library they talk about. So the standard library is essentially a library of functions and processes that are available to you as a programmer. They're made available inside the C, inside sort of the native part of C++. And the idea is that a lot of those functions and a lot of the things that the standard library offers you, so you don't have to code it up yourself. And we'll sort of talk more about that as we go, because it'll be ubiquitous in all the programs that we write. But the standard library is, again, just a set of functions and operations that make all kinds of things available to you. Similarly, the math class is there too. You'll be using that. You'll be using that for this for project 2.2. Any kind of math operations or arithmetic operations that you're going to want to do, you'll need the math class to do that. And then they've got a section on character and string variables too, and I think most of that's pretty straightforward. We've got a separate chapter, I think, where we go more in depth on strings. So I'll say more about those when we get to that chapter. And then just generally, just to make sure we cover the bases, a variable simply is a address space in memory where some value is stored, okay? So it could be a number, it could be a string, so it could be a string of characters or string of text, and it could also be numbers, but just think of a variable as a place in memory where a value is stored, okay? All righty, so let's jump in and let's do a little bit of coding. I'm going to share my desktop and I'm going to start up Xcode, and we'll create a new Xcode project here. So again, I'm in Mac. Your interface, if you're on Visual Studio, it'll look a little different. I'm going to call this paycheck underscore calc. And I'll just put this on my desktop. It's going to be fine. Okay. So again, out of the box, notice we've already got comments up top here. So I've already got my name. And again, what I would ask you to do is, you'll also do put the class, so CSC 134, and then you'll also put the date here too, although technically the date is already here. Yours, again, may be already including this stuff, so in which case you'd only need to put the class, but I'll go ahead and put let's see, 24 June 2020. And you may be watching this way in the future, in which case that'll be an older date, but you sort of get the point. I want to see your name. And even if you're modifying an existing program, like some of the book exercises you'll be doing where you'll be asked to open an existing program, I want you to go in and modify the comments there and put your name, the class, and also the date, okay? So out of the box, again, first thing I like to do is run this, compile and run it, just to make sure there's no issues. So it'll take a couple seconds for that to happen. All right, looks good. I got my hello world here, so we're good to go there. So notice IOStream, at least the default for me is IOStream is already there. So that takes care of our standard input and output, right? So for instance, in this case, we'll be creating a paycheck calculator. So in fact, I'm just going to go ahead and modify this and say, I'll call it paycheck calculator. And then, so let's look at the requirements here. So I'm looking at the paycheck calculator. So we see the example on the console here. They give us the formula for gross pay. They give us a formula for the tax amount, and then they give us a formula for take-home pay. We're just going to get, I think all I'm going to do here is just do some basic math just to sort of get you going, and these should be all fairly straightforward here. I mean, hours worked times, or this asterisk is going to be multiplication in C++. So hours worked times the hourly rate, and then the tax amount gives you the gross pay multiplied by. Then notice these parentheses here. There's a section that talks about how math functions are prioritized in C++, and basically the parentheses mean that, hey, we're going to do this calculation first. So in this case, and the / is the division symbol. So in this case, we're going to be dividing the tax rate by 100. So that math would take place first, and then we would multiply that times gross pay, okay? So let's put that back up here. And so I'm going to go ahead and get, so in this case, we're going to want, and again, if we just look at the sample output, we're going to want to get hours worked. So in fact, I'm just going to copy this and paste it in twice. And let's go ahead and put some space here. Generally, just to walk you through the software. So the software development process, when you're solving, generally it's a good idea to sit down, and you may even want to write it, scratch it out on either a whiteboard or a piece of paper, sort of write down the calculations you're going to do first. And then lots of times what I like to do is when I come into the program, I'll actually make comments on the things I'm going to do just to sort of structure the code. So for instance here, I'm going to say, let's see, I'm just going to say introduce, or this would be, let's say it'd be the program title, right? So the user knows, okay, what the heck this program is. Next thing I'm going to do is get hours worked, all right? So I don't want to do that. Next thing I'm going to do is get pay rate, okay? Down below that, I might calculate results. So let's get hours worked, okay? So the first thing we need to do is we need to create a variable for this hours work, right? We're getting input from the user, so we need some variable to hold that value in memory. So later on, when we want to do a calculation with it, we're able to call on that variable. So in this case, I'm just going to call this, I'm going to make it a double, and I'm going to call it, just keep it simple and call it hours, okay? And then for my output, I'm going to say hours worked. We'll do something like that. I'm going to remove, so by removing that carriage return, that \n actually moves your cursor down to a new line. By doing this, when I actually run this, in fact, let's run it now. Well, let's go ahead and get the input first. So we're going to see out, and then I'm going to see in. So we're going to see out hours worked, and then we're going to call, you know, for some of you, you may not need to call this standard here. I'm calling this STD, and I think they discuss this in the book. I'm being explicit about how I'm calling this. You could also add the standard library at the top. And in fact, we'll experiment this in a second just to see, but you can call the standard library at the top, and you don't need to call that explicit path, call that STD. So I'm going to do CN, and then in this case, it's going to be hours, right? Because that's the variable I want to assign this to. Now I can go ahead and run this now and test this out. I mean, the other thing I always like to mention is too, you know, if you have these kind of errors here, and again, Visual Studio is going to be very similar to this. The IDE is constantly looking for any syntax errors or issues with your code. So if you see errors like this, go ahead and take care of them, because I mean the program is not going to compile and run correctly if you don't take care of those things. So as you're coding, I see students just sort of plow through, and then they've got a mess of code that's got, you know, a dozen errors in it, and it can really be overwhelming to try and fix those. So as you code, and as you sort of break out the various small tasks that you're doing, in this case, all we want to do is get the hours from the user. You know, make sure that code is correct, and then go ahead and run it. Go ahead and compile and run it. And so, for instance, in this case, you notice it's getting. I'm being prompted down here at the bottom for the hours worked. So if I say 24, hit return. Okay, it runs. Now again, I'm not doing anything beyond that with the code, but at least I know so far so good, right? The code runs. I'm getting this variable, or I'm getting the hours worked from the user, and I'm assigning it to this hours variable. Okay. All right. So let's do. Let's go ahead and get. We might as well get the pay rate while we're here too. So let's go ahead and do that. So I'll also make this one a double. I'll call it pay rate. All right, and so similar to what I did up here, I'll say pay rate, colon, and then I'll do a CN. So I mentioned that. Let's see, in fact, if I remove the standard library here, this will still run. So, okay, so you're right. So in this case, it does not. And I think the book talks about that. You can add the standard library, and so you don't have to do this. So you've really got the choice to do it either way. It's really up to you how you want to do it. I'm fine with either one, but you can include. I think you use the using statement. You can do using STTD, which is a standard library, and then you don't have to append this STD with the 2 colons on the front. But it's a bit less coding if you include the standard library first, so you don't have to append all of those methods with this STD at the front. Okay, so I'm getting the pay rate here, and then I'm going to do a so I do a CN statement, and I'm going to assign, again, whatever the user inputs, I'm going to assign that to pay rate. Okay. All right, and that looks okay. Now, just to do some real simple math here, I could do, I'm just going to do something like result. So I need to, I'm going to say double result equals, let's just say hours times pay rate. All right. And then if I wanted to output that, I could do something like std cout, and then I'll say just do result like that. Now let's see if this gives us an error. I think it will. Sometimes you have to wait on the ID to catch up. Okay, it's not throwing an error, so let's try and run it and see what we get. So I didn't need to include the math class here. Let's keep our math easy since we're just multiplying. Let's just say 10 times 10. Pay rate is 10, so we should get 100 here. So yeah, notice we got 100 here. Now notice one thing I didn't have to do is include the math class here. So just depending on your IDE, you may have to, by default, I'm including IOStream. Notice I'm including CMath here. And let me go ahead and put a, just to sort of clean up my \n, see if it likes that, just to clean up my interface a bit. So no, that's not allowing me to do that. Yeah, that's not allowing me to do that. Just wanted to get my carriage return at the end. But let me make sure this runs with CMath. It does. So you may need to include that. Visual Studio users, you may need to include CMath at the top. It really just depends on the ID you're using and maybe how your configuration is set up. Mine was set up such that I didn't have to add that at the top. But again, if I say 10 times 10, notice I get, notice I get 100. And I think actually the concatenator here is, let me try one more thing. \n. Okay, it seems to like that. So now if I do 10, and I do 10, yeah, that's just one of my little bugaboos. I hate it when this program ended. It is butted up against it right at the end, and you really can't see what the result is. Okay, so I think that's all I'll do. It'll be up to you. That's just generally how I would structure the program and begin. It'll be up to you to implement the formulas that they give you inside Project Tutu. But a couple things here. Utilize this process of creating comments inside your program to sort of think about the high level things that you want to do. So again, with a program like this, based on the requirements for the paycheck calculator, generally the high level things you're going to want to do, and you can make comments are, hey, I'm going to display the program title. I'm going to get the hours worked. Now, when I say get hours worked, that includes displaying a prompt to ask the user for the hours worked, and then also getting that variable and assigning it, in this case, to the hours variable, get pay rate, and then we're going to calculate the result down at the bottom, and then of course we'll display that at the end. Okay, so that's just a little bit about chapter 2. Good luck, and let me know if you have questions.